what's up? We're talking about domain and range. This video specifically will focus on domain. Make sure you check out the other video to learn about range. Okay, so domain and range, think of it as the boundaries of our graph. We're trapping it inside. So we're seeing like what's the left to right that it can go and what are the values for the lowest to the highest that it can go. Okay, so we're building the trap. Got to keep it inside. It can't escape. So here we go. Domain. Domain is the set of all possible x values for our graph. Okay, so we're going to be looking, what could x be? What could the x coordinate be in this graph? And we're going to create those boundaries by looking left to right. That's the lowest x value to the highest x value. Okay, and I don't want to get confused with range. So left to right, left to right. That's what we're thinking every time. As an inequality, it's going to look like an x sandwich. Okay, so we're going to have the furthest left value. Then we have our inequality. X is in the middle. That's why it's an x sandwich. Inequality, and then the furthest right x value that you have. Right? So that's what it's going to look like. Remember the difference between closed and open dot. Closed dot is or equal to, so it is part of the set. Open circle, it is not equal to, so it's not part of the set. Let's look at what this means. Okay, I have a graph, and I want to find the domain. So the domain is my boundary left to right, the x values, x values. Okay, so we're making the x sandwich. So I look to the left, and I find this point right here. Awesome. Okay, so I'm right there, and this is at -3 for on my x axis, right? So that's the furthest that my x values go. Notice if I go to -4, my graph doesn't come out here. There's nothing there. That's why we don't go past it. We created the left boundary. It's a closed dot, so we say or equal to. Okay. Since these are my notes, let me write a little bit more details here. So that's my left value. This is equal to because it's a closed dot. X always goes in the middle for domain because it's the x values. All right, and then I look at the right side. I say, hey, that's the furthest my graph goes on the right side. That's at +4. So it's going to be, and it's an open circle this time, so it's not or equal to. So it can't be 4, but it goes up to 4, right? So that's how you create a domain for this graph. And what does that mean? It means that our x values, any x value between -3 and 4. But we can't include 4, so not including 4. Right? Or you could say x is greater than or equal to -3 and less than 4. Right? That's our sandwich. It's in between. It's kind of like those lasers, right? We set up the walls, and if I set my laser beams going, it should trap the whole graph. It does. Awesome. That's what we're looking for with domain. So let's do it again. Okay, furthest left. So I'm looking at my graph, and I'm saying, hey, furthest left is right here at -2. So there's my left boundary. It's a closed circle, so it's less than or equal. Remember, we're always making the x sandwich, right? And I look for the right, okay? I'm at 1. We're going to pretend my lines are super straight because I'm not an awesome super straight line drawer, right? Okay, so it's less than because it's open. And it's at 1 because that's the furthest left of my x values, right? So again, draw your laser beams. Hey, I trapped it. That's what I want, right? So any x value between -2 and 1. But not 1, right? Because it can't equal it. It gets really close to it, but not equal to it. All right, you feeling this? You doing okay? Domain, left to right, x values. Okay, so I'm looking furthest left is right here, -1. Open circle means just less than. Put my x in my sandwich, and I look at the furthest right it goes. I'm at 1, 2, 3, 4. It's a closed dot, so or equal to, and get my 4, right? Remember, draw your laser beams. Hey, I trapped it. Yay, it's good. All right, so any x value between -1 and 4, but not -1, right? Because -1, it's not or equal to it, it's that open. So x is never actually -1, but it goes all the way up into that border, right? Okay, do it again. Oh no, there's an arrow on my left. What in the world does that mean? Okay, the arrow just tells me that I go on forever. Right, that's what it means. This is represented mathematically with infinity. And since it's going towards the left, that's my negative x values. Okay, so it's negative infinity is my left boundary. If you have the arrows, that means forever. That's your infinity right there. Okay, let's go look at the right side. Okay, I'm right here. That's at 2. It's a closed circle. So, oh wait, I didn't finish my sandwich. So less than, because we're never equal to infinity. And then less than or equal to 2. Okay, but something cool happens when we have infinity. So I can write the sandwich, right, with the left and the right value. But I can also, if I ever have infinity, I can drop that part of my inequality. And I can keep the other side. So this would be x is less than or equal to 2. These two inequality expressions, they tell you the same thing, okay? But just know that whenever you have any infinity as part of it, you can drop that half and keep the other part of your sandwich, and that is what you have. That's your domain. What this tells us mathematically is that our domain is all real numbers less than or equal to 2. Okay, because right, I can be 2, and then I could also be negative. I could be 1, I could be 0, I could be -3, I could be -5, I could be -100 because it keeps going. All real numbers because, yeah, you're going to get into imaginary stuff, guys. It's okay. Not yet. Not yet. All right. Do it again. Okay. Domain. Always think domain, left to right, left to right, left to right. Okay, so here we go. Furthest left I'm looking. My graph goes to right here. That's -1, 2, 3, -4. Okay, so now is it open or closed? It's a solid line. Guys, it's always closed unless you actually see an open circle there. Okay, so since this is a solid line, it's going to be less than or equal. Put the x in the sandwich, and we go look at the right. Whew. Hey, it's an arrow. Remember, the arrow tells us goes on forever. So our other side is less than infinity. This time it's positive because it's going to the positive x values. Look, if my laser beams were to go off, this is going forever that way, but I still trapped my graph, okay? Don't get thrown off by this point being open because right above it, it's closed. Closed always trumps open when we're working with domain, okay? Because we're saying what are the possible x values? Well, this one can be, just not when the y value is that, right? But it still could be that, so we have to include it in there. All right, so remember what I told you. If we have infinity, we can drop that part and we can keep this one. Okay, and what I want you to know, so we would have -4 is less than or equal to x, but get really used to reading it backwards. Like if I held it up to a mirror, it would say x is greater than or equal to -4, right? So x is greater than, so we're going this way because -3 is greater than -4. 1 is greater than -4. Okay, so double check with your graph. Did you give it the right meaning? Okay, and so we would say all real numbers greater than or equal to -4. So again and again, over and over, left to right, did you trap your graph? Okay, one more for good practice. Here we go. Furthest left, hey, I got an arrow. Okay, so furthest left is negative infinity. Remember, we can't equal it. Put my x in there for the sandwich. And I go look furthest right, so I'm like following my graph all the way to the right. And hey, I hit another arrow. Oh, this is going to positive infinity for my x values. Okay, hey, infinity to infinity. If it goes forever in both directions, our domain is all real numbers. Okay, if it goes on forever, it's all real numbers. Guys, that's domain. Left to right boundaries. Left, look to the left, look to the right. Trap it. You should be able to draw your laser beam, and it should cover and trap your graph. That's a way to check it. All right, remember to check out range so you know both of these.